In this video, I'm going to focus on a single operator, the Script SOP. As a surface operator, it has to do with points and primitives and curves, but everything is controlled by a Python script. If you have other SOPs connected to it as an input, you can use it to add or modify or delete points and primitives. In our case, we don't have any input. We're going to create a geometry using only the Script SOP. I needed to create some custom geometry for another project that I'm working on, and I learned quite a lot about the Script SOP, so I decided to put together a video and share some of that. The documentation is quite helpful, but a few things might not be as straightforward. If you have some experience creating geometries in other languages and you come to TouchDesigner, a few things might be a bit different, so I hope this example helps. And the geometry we're going to be creating is a tube. Now, of course, you can just drop a tube SOP and carry on with your network. You don't need to bother with any of this. The point here is just to try to understand how geometries can be created using the Script SOP. And this is not going to be an exhaustive tutorial on all of the features of the Script SOP, but hopefully I'll show you enough so you can understand how it works and then carry on and work with the other features. Right, so let's delete this and start from a fresh file. Let's drop our Script SOP, and we need to arrange our windows here to make it easier to see everything at once, and we can work with this script here. So let's click on this dot, click on edit to launch external editor. In my case, it's Sublime Text. It's going to align it here with the left of the screen and then put TouchDesigner here. Right this with the right of the screen and put TouchDesigner to the left. I can dock this in here and we can hide our parameters and zoom in closer to see our viewer. And I also want to split my window here top to bottom, and I want here text port and dots so I can log out messages and also see eventual error messages. Now let's have a look at the script. TouchDesigner already gives us three functions here. Setup parameters, we're going to leave it as is for now, just come back to this later. On pulse, we're actually not going to use, and on cook is where most of our scripting is going to happen. So let's clean this up a bit. Let's get rid of the comments. And I also want to replace this Script OP by just OP, just because it's easier to type. So just lowercase op. And now let's have a look at what we want to do here. Here's a simplified drawing of a tube, and we can see the components. So we have a top part, there's a bottom part here as well, even though it's hidden, and we have the main body. And all of those are made out of segments. For top and bottom, we have the radial segments, and for the body, we have the height segments. So these are already our first variables that we need to add to our code. Here inside onCook, let's create our first variable, which is going to be rseg for radial segments, and I want to set it to 5. Then hseg for height segments, and I'm going to set it to 2. And since we're here, might as well just add a third variable called radius and set it to 1. Now, geometries are made out of points and primitives, and we have to start with the points first. If we were to look at our first radial segments from the top, this is how the points would look like. They would be equally distributed around this imaginary circle here. And we can do something like this using a for loop and some trigonometry. Back to our code. To use trigonometry, we want first to import math. So here in the first line of our onCook, let's just import math. And now we start with our for loop, which is going to be for j in range and the range is the number of radial segments. Now to append a point to our operator, we need to call OP append point. We can store this in a variable, which I'm going to call P, and now we can use P to set its components. We'll start with X and type math.cos, and I want to pass the full circumference of this circle, so math y times 2 multiplied by the ratio of where I am now in this loop and the total number of items in this loop, which is our rseg. And then I can multiply this by our radius, which at the moment is just 1, so it won't change anything. Now for y, I can duplicate this line, replace x by y, and replace cos by sine. And for z, we can set z to 0. Now if I save this, we have our first 5 points. Let's make this a bit easier to see. Open the display options, toggle points, and point numbers. Now I can see 0, 1, 2, 3, 4. These are the points for only one of the radial segments, and if we want for all of the height segments, we just need to wrap another loop around this. So we can start here with 4i in range hseg. If we save that, see we have more points, but they are all on top of each other. That's because z is 0 here. So let's change that to I, and now we have 2 sets of points. Now looking at our 2 layers of height segments here, we want to start connecting these points and making our first primitives. So if I start from 0 here, I can make a triangle with 1, 6, and then back to 0. And in this case, the order in which I connect these points is important in order to calculate the normal. So if I use clockwise, the normal is going to be facing one way, and counterclockwise is going to be facing the other way. And I know that the order we're after is counterclockwise. Back to our code, let's create our first primitive. And a primitive in this case is called a poly. And we need to append the poly to our operator. So op.append poly. And we can also store this in a variable. I'm going to call my variable poly. And we need 3 parameters here. The first is the number of vertices in this polygon, which I'm going to pass 3. The second is whether we want it to be closed, and we do want that, so closed equals true. And the third parameter is whether we want points to be automatically added for this polygon, and we don't want that because we're going to add our points manually. So let's pass add points equals false. This polygon is made out of vertices, and we can access each vertex by calling poly and then square brackets and then the index of the vertex. The vertices contain points, so we can access the point of each vertex by typing dot point. And in this case, I want to set the first vertex of my polygon to this point number 0 here in my operator. So I need to go back to my operator, go to the list of points, and then pass square brackets 0. The triangle that I'm trying to create goes from 0 to 1, 6, and then back to 0. The next one here, the next vertex is going to point to my point 1, and the third vertex is going to point to point number 6. If I save that, you can see we have our first face there. And let's also play the surface normals, or the primitive normals. And we can see that the normal is pointing outward as we wanted. If we were to swap these 2 vertices here, now the order is clockwise, and we can see that the normal is pointing inward. So we want counterclockwise. Now if we look at this again, we know that our next face is going to be between 0, 6, and 5. So let's copy these lines here, paste them again, and then first one is 0, second one is 6, and third one is 5. Save that, and we have our second face. Now we need to rewrite this to make it a bit more dynamic, so we can do the same for all of the faces here. Sometimes I'm using the word faces to refer to primitives, but I mean the same thing. So we need to put this inside another for loop. Let's type here for j in range rseg, and in this case we want rseg -1. Let's increase the indentation, and we also want another variable that we can increment manually, and I'm going to call this k. I'm going to set it to 0. So k starts as 0, and I know from our first face here that we want 0, 1, 6. So to find 0, I just using k, I just type k plus 0. To find 1, k plus 1. And to find 6, I want k plus the number of segments, of radio segments, which gives me 5, plus 1 to get 6. Now go on to the next face, that will be k plus 0 again. 6 we've already seen, it's k plus r seg plus 1, and to find 5 it's k plus r seg. Now I just need to remember to increment my k here before we leave this loop, and save that, and we have faces for almost all of the points here. We're only missing the last ones. That's why we used -1 here, because the last one is slightly different. It's still very similar. We just need to do those last two faces outside of our loop. So let's copy these lines again. So outside of our loop, and this time the first face is going to be between 4, 0, and 5. Let's comment these lines out. Just want to print the value of k here. If I print k, I get 4. So I know that if I use k plus 0, for example, or just k, that would give me 4. First one is already correct here. K plus 0 is 4. Now I want to find 0. To find 0 starting from 4, I need to subtract radio segments and increase 1. And if I want to find 5, I just need to go k plus 1. I save that, I get our face here. And next face is going to be 4, 5, and 9. Copy this once again. We know that 4 is k plus 0, 5 would be k plus 1, and 9 would be k plus r seg. And now we have all of our faces. If we want faces for all of the height segments, we just need to put this inside another for loop. Similar to what we did before, we type for I in range, then hseg -1, and we need to remember to increment our k variable here one more time after our second loop. We save that. Now if I change the number of height segments here, let's say to 4, and save it, and see that all the faces are getting created correctly. We don't want to be changing the number of segments directly here, when we can use the setup parameters for that. So let's bring this back to 2, and let's focus on the setup parameters for now. I'm going to press B here to show our custom tab. We can see value A and value B, and this could easily be radio segments and height segments. Let's change that. First one is going to be radio segments, and the second one height segments. The internal values are going to be radio and height. Save that, go to script, press setup, and see that those values changed here. Now you might find it strange that I call this radio and height. If I try to call this radio segments with a capital S, save this, press setup, I get an error that says that the parameter name needs to begin with an uppercase letter followed by lowercase letters and numbers only. So TouchDesigner doesn't like this capital S here, and I personally didn't like lowercase s here, so I just call this radio and height. Hit setup again. Now our parameters are back. We can clear the error message. Now let's have a look at the slider here. It's going from 0 to 1, and we can see that it is a float number. Let's change that because we want integers here. So instead of append float, let's type append int. And we can give ourselves some space here. And I want to set the minimum and maximum values to something else. In case of radio segments, I want p.min to be 3, and I want the maximum to be 64. If I save this, go to script and press setup, get an error. It says tuple object has no attribute min. And that's because this p here doesn't return the parameter directly. In order to access the parameter, I need to find the first item, which is square brackets 0. Now save this, setup, and we still have this between 0 and 1. And that's because the slider is using normalized values and it doesn't know anything about our min and max. So let's update that. So p.norm min equals to p min, and we can duplicate that line and do the same for max. Save it, go to script, press setup, and now our radio segments are going from 3 to 64. If I try to type 100, it will let me do that because the values are not clamped. So let's update that as well. So p.clamp min equals true, duplicate the line, do the same for max, save it, update the script. Now we can try to type 100 and it will bounce us back to 64 because now the values are clamped. Copy those lines and do the same for height here. Let's not forget to add our square bracket 0. In case of height, I want the minimum to be 2, maximum can be 100, and I don't want to clamp max, so I'm just going to set clamp max to false. While we're here, we might as well create a third slider for our radius, and in this case it can be a float. Let's update the internal value to be radius. Table can also be radius, and minimum can be 0, maximum 10, and clamp max false is fine. We replace our hard-coded numbers here by these parameters. So our seg is going to be equals to op.par.radial.eval. Height op.par.height, and radius op.par.radius. Save that. Hit setup one more time, and radius is 0. Let's set radius to 1. Now we can see that our sliders are working just fine. Next, let's add some end caps to this, some top and bottom faces. But first I want to organize my code here a bit so I know where I can find things. I'm going to add a separator here, and I'm going to call this points. Copy this separator, paste it down here, call these primitives. And here I want also a comment saying that these are the points for the body. Here are the primitives for the body. Now top and bottom, we can call them head and tail. And I know that if you inspect the tube geometry, you see that the points for head and tail are created after the body, and the primitives for head and tail are created before the body. Points for the head, they're very similar to any other radio segment. So we can just copy these lines here, fix the indentation, and in this case PZ is not I but 0. We save that. We can see that we have some new points which are overlapping our first layer of radio segments here. It's not very easy to understand what is going on, so let's create the primitives as well. And the primitives are going to be another poly, So we can copy this line, but instead of only 3 vertices, we want as many vertices as segments in our radial segment. So just pass our seg here. Now I can loop through these vertices. So for j in range r seg, type poly square brackets j to poly square brackets j to access each vertex, and then dot point, and it's going to be the OP points again, and I need to work on the index here. The index needs to start after all of the body points. I can store that in another variable, which I'm also going to call k, and that is the total number of height segments multiplied by the total number of radius segments. It's starting from k and incrementing j on every iteration. Now we save that. We can see that we have face there, but it is not facing the right direction. So we need to invert the order of these points. And we can do that with a decreasing loop. So we say rseg -1, and it goes to -1, and we increment it by -1. And just so you know what is happening there, we can print j, and you can see that j goes from 4 down to 0. Now our face is pointing the right way. Now if we were to inspect the end caps of the tube SOP, we would notice that it uses an extra point. And let me show you that. I'm going to go to Model Geometry, and let's select this face, spin this around, let's show the numbers, and our face is going from 10 to 14. We have 5 points here, but if you inspect the tube SOP, you would see a 6th point here overlapping number 10. I think that TouchDesigner needs that in order to calculate the surface normals correctly. So let's follow that and add extra point here. So rseg +1, rseg +1. Let's change our loop to start not from rseg -1, but just rseg. So this goes from 5 to 0 now. Save that. Not much changed, and we will know later when we see normals that the normals are working correctly. Now for the tail, it's pretty much the same thing. We can copy these lines, and the difference here is that pz is not 0, but the total number of height segments -1. And the loop doesn't need to decrease, so we can delete that and just type rseg +1. For the primitives, we can also copy what we did for the head, and the starting point is going to be all of the points for the body plus all of the points for the head. Save that, go to the other side of our geometry, and we can see we have both head and tail as expected. We might want to have that as a toggle in our parameters, so let's add an extra parameter here. We can copy this line, and we're going to call it caps. The label is going to be end caps, and I'm going to store that in a variable called caps, so op.par.caps. Now I can wrap a conditional around these lines, so it says if caps, and the same for the primitives. Let's paste if caps, fix the indentation, save this, and we need to hit setup one more time. Now you can see, oops, this is not a slider. We need to change this from append float to append toggle. Let's hit setup one more time. Now we have our toggle. Turn our head and tail on and off. Next, let's add point normals. And normals are attributes of the points, so we're going to add them up here. And in order to create an attribute, I need to type op.pointAttributes.create. And in this case, I'm going to use the default uppercase N, And we can access the attribute of that point by typing p for the point that we created up here, dot uppercase n. And this has three components. We can pass here px, py, and 0 to get our normals. So if we save this, let's press P here to toggle our point normals, and we can see that we have our normals now. Now this is not entirely correct because the normals are getting stretched according to the size of the point. If I increase my radius, I can see that the normals are growing together with the shape. Let's fix that. And for that we need another class, which is a vector, tdu.vector. And it also has three components, so we pass px, py, and 0. I'm going to store this in a variable called n, and then I'm going to normalize this vector, so n.normalize. And now we can use n here instead of p, so nx and y. Why not? Let's use also nz. Save this, and we can change the radius now and see that our normals are now staying the same size. This is correct. For head and tail, it's a bit simpler. We can just copy these two lines here because it's much easier to calculate their normals. For the head, normal is going to be 0, 0, minus 1. For tail, 0, 0, and 1. So save that, and we can see we have normals for all of our points, which we can also switch on and off by adding another toggle to our parameters. Let's duplicate this line here, call it normals. Label can be compute normals. Store that in a variable, call it norm equals to p-par normals. And again, let's use a conditional around these lines. So if norm, and then again if norm, and one last time if norm. Save that, to press setup. Here is our toggle. So I think this is it. We wrote about 130 lines of code. We covered append points, we covered append poly, and also we're creating attributes. And we also covered a bit of the custom parameters. So I hope you found this useful. If you have any questions, feel free to ask. Otherwise, I will see you in the next video.